Hi, my name's Jason Gamitter. I'm a principal systems engineer with Cisco. What I want to do today is take you through Tetration analytics and help you understand how it can help you solve some very complex problems and help you answer some also very difficult questions that we've been trying to solve over the years. So first, let's start with how can you consume Tetration? Today there are now three ways. You can consume Tetration as a service. You can consume Tetration on-premise. And there's two ways on-premise. Number one, a physical appliance, very large long-term data lake, as well as a virtual appliance. Essentially, I could be a small customer, or I want to test it out in the lab. I can run Tetration on a small virtual appliance. So I can start very small and grow very large, or I want to just consume it as a service like I do other SaaS offerings. Now, what is Tetration going to help me solve? Well, we got to start with what are we doing differently? So number one, we need to turn the lights on within the enterprise. We need to be able to understand all communication patterns, north, south, east, and west. And out of the box, Tetration offers three sensor types. The first one is a software sensor. Now, the beautiful thing about a software sensor is it's infrastructure agnostic. I don't care what your network switching infrastructure is. I don't care what your compute is. I don't care what cloud provider you use. As long as it's a supported server operating system and I can install that in user space, I can get the telemetry that I need to Tetration for it to do its job. Also being infrastructure agnostic is the out-of-band sensor. I'm not always going to be able to get a software sensor installed somewhere. But if I can grab a port mirror off of a VMware DVS, or maybe an ER span session off of a switch, I can say, this data I'm interested in, send that to the out-of-band sensor and grab the telemetry that I want to get over to Tetration. Now, the third option is a hardware sensor. If you're a Nexus 9K EX or FX or FX2 customer in ACI or NXOS mode, any packet that enters an interface, a front panel interface, or with FX or FX2 ingresses or egresses out of those front panel ports, we're going to grab the telemetry that we want to get over to Tetration. Now think about this. We're streaming this telemetry from these three sensors, all three of them. Every 1 second, they're streaming telemetry to our platform. It never stops learning. So let's take a moment and understand how are they similar and how are they different. Now, if we look at a packet, there's a payload and there's a header. What Tetration cares about is this packet header. What we do, software, out-of-band, and hardware sensors, is we grab up to 160 bytes of metadata or signals from that packet header. We don't sample, we don't touch the payload, but we give you up to 160 bytes of metadata about each and every packet header that makes up a flow. And we stream that every 1 second to this platform. Now, where do they differ? Well, the software sensor grabs some really rich contextual data. It helps me understand what's the server operating system. That's useful. What are the sockets that are open on that endpoint? How about what process is tied to that socket? I see well-known port TCP22. Oh, it is in fact SSH. Great. Well, what was the command line argument that was used to launch that process that opened that socket that we correlate to a flow? Really rich data. How about what software is running on that workload? And tell me what version it is. Start recording what are all the processes running and grab me what that process hash is. We grab that information as well. And we stream that to Tetration. Out-of-band sensors going to grab me that metadata about each and every packet header that ER span or port mirror session sees. Hardware sensor, not only will it give us that per packet telemetry, but it's also going to give us some additional data points around this flow went across this path across an ACI fabric. Were there any drops in the fabric? What did latency look like on a hop-by-hop basis? Were there any bursts? With bursts, were there any drops? All of that gets streamed to our platform. Now we know, I said in the beginning, we want pervasive visibility. I don't want any dark spots. So what else can I use to make sure that I have the lights fully turned on? Well, we have NetFlow, V9, IPFix from third-party vendors like F5, Citrix, or Avi. We will stream into our platform. I'll take in VPC flow logs from Amazon, AWS. And then lastly, if you're an AnyConnect customer today, there's a module called NVM, Network Visibility Module. And what that does is it streams IPFix data about everything that PC or laptop or virtual instance is doing on the network. Now, it doesn't need to be running, it doesn't have to have a VPN launched. It just needs to be connected to a trusted network. So plugged into the campus, connected to the wireless, or on a VPN. And that NVM session will stream everything that endpoint's doing with 10 additional contextual data points like what's the device, what's the operating system, who's the user that owns the device, that owns that current IP address, what processes are they using, what are the process hashes, what are the domains they're visiting, and all of that gets streamed to Tetration. That's how we get pervasive visibility. Now, what we also do when we start to look at all of this data coming into this platform is we want to enrich this data even further. What we want to take from you is, do you have any CMDB information, any IPAM information that we can use to further enrich the context about those endpoints or subnets? So let's take a moment and think about that. What would be important data point for me? I would love to know lifecycle. Is this a dev or a production workload? What about location? Is it out in the public cloud or is it on-premise? If it's on-premise, what data center is it in? What about, does that workload need to be quarantined? We can have simple tags like yes or no. You can go on and on, but basically you can have up to 32 additional identifiers that represent any endpoint /32 or any subnet that further helps Tetration understand what's going on across your infrastructure. Now, what are we going to do with all this data? That's a lot of data coming in. Now, what we do is we have different applications inside of Tetration. It's not a single tool. You have all these different apps that help you answer these questions and solve these complex challenges. Well, number one, the first app is Tetration's a DVR. Everything that we collect, we store within an integrated data lake, and we make it searchable. Not only do we make it searchable, but we make it fast. We give you a 2-second SLA, no matter what you search on, if it's 5 minutes ago or it's something weeks or months ago. I guarantee you that query is going to show up in under 2 seconds. Now, this is where it starts to get really cool. Tetration is an ADM platform. In a zero-knowledge environment, you know nothing. Tetration is going to start to dynamically discover your application's dependencies. So what that means is now I understand what's depending on my app. What are the end users? What are the business partners? What are other applications that touch my app? But also, what is my app depending on outside of the environment? How is the web tier talking to the app tier, the database tier? So we start to get a visualization of web endpoints, app endpoints, database endpoints that represent my application. And the next piece is we start to understand how are they communicating? What is web consuming from app? What is app consuming from database? What about these different endpoints here that are touching my web tier? So you get your dynamic clustering of endpoints. You don't need to tell Tetration these endpoints are web. We'll discover it for you. Most customers don't know. I don't want to force you to figure this out on your own. Tetration's going to dynamically discover it for you. These are your web endpoints for this app, the app tier for this app. And then this database is actually a shared environment. And then these are the different end users or business partners coming in to access this application. And then part of this is we discover your first iteration of a true zero trust policy. I want a micro segment, but it's so hard when I don't understand what that policy should be because I don't want to break something. So Tetration discovers that for you. So we have ADM that includes the mappings and the whitelist policy. Now, just as important as discovering is testing. How do I know it's accurate? How do I know I've captured seasonality? The last thing I want to do is go and enforce a zero trust policy and I break something. Now keep this in mind. We've discovered this policy. Kind of think of it logically standing this way, and I have this telemetry coming in. We play it against that policy, and that's our next app, policy simulation or policy analysis. Tell me what would happen if I put this in production. I enforce these rules in production. What flows would be permitted? What flows would be denied? And the flows that would have been denied is what I care about, because it helps me understand there's seasonality in my application I first didn't capture. Something different is happening on the wire. I now see it, and now I can make an analysis. Is that benign? Meaning, oh, that app makes a backup at the end of the quarter I didn't capture when I first ran my ADM algorithms. Or is that possibly something malicious happening on the wire? If this was in production, we would have blocked it. Or I can even go back in time and replay old data and say, if this policy was in place back then, what would have happened? So now we get to the really cool part. Enforce. Tetration has a unique capability where we give you two ways to enforce. Number one, if you have that software sensor installed on bare metal, virtual, or you have a Kubernetes or OpenShift environment, we drive a unique policy down to each and every endpoint that has that software sensor installed. And we keep that policy up to date at all times. If someone clears the IP tables, we put the policy right back on. If someone adds a new rule that shouldn't be there, we replace it with the proper rules. So no matter where that workload exists, public cloud, on-premise, out in the branch, you have a single interface for a consistent policy across those endpoints. Now, I think we all agree defense in depth is the right thing to do. Every policy that we discover, we publish to a Kafka message bus. So what that means is, if I have a Kafka message bus here, Tetration publishes that policy here. So what that means is, well, have ACI plugin, have F5 plugin, have a firewall plugin, and ask that bus, I want policies for these subnets. I want policies for these IP addresses. And it will pull that policy off, normalize it into their own language, identify what resources it has available, and then implement that policy in the infrastructure. So I have defense in depth, fine-grained policy at the endpoint, coarse-grained policy I can push within the infrastructure. So think about, from an ACI perspective, my clusters that we've discovered become EPGs in an ACI world. And those zero trust policies we discover between web and app become contracts and filters in an ACI world. Defense in depth, it's a beautiful thing. Now, next up is compliance. We've discovered the policy, we've tested it, we're enforcing it in multiple places. Telemetry continues to stream in. Now I know at any point in time 4 things. Permitted, misdropped, escaped, and rejected. So what do those 4 things mean? Well, I have a zero trust policy. I'm seeing data on the wire. And we're not looking at logs. Logs is not an effective way to do compliance. We want ground truth, what's actually happening on the wire. So as this telemetry comes in, we see this flow happened. Yep, that matched one of our policies. That is in compliance. We see misdropped. We saw a flow try to execute, but something in the infrastructure dropped it. It was not able to complete. Someone possibly implemented the wrong rule. Escaped. There was no whitelist policy that should have allowed communication. However, we're seeing 2 things communicate that should not be allowed. Things are out of compliance. I want to alert my SIM. And then rejected. There was no whitelist policy, and we are seeing our infrastructure block those flows accordingly, but someone's knocking on the door trying to get in. So now what we've done is, for an individual application, we've discovered this beautiful granular micro-segmentation policy. But it doesn't stop there. Because if you remember, we're also grabbing a software inventory. What can we do with that? We're also grabbing process hashes. What about that? So the next up is software vulnerability detection. So what we're going to do by taking that software inventory is we're going to essentially compare that to a well-known MITRE or NIST database, so we can understand at any point in time what workloads are running vulnerable software. And then we can make a corrective decision on how we want to deal with that. So not only are we micro-segmenting, for instance, port 80 and 443 to a web server, But I also know if that server is running vulnerable software that can still be potentially hacked over those open ports. Let's get those workloads cleaned up, all still with one sensor, one platform. Now, what about process hashes? Tetration will also go out and pull in from VirusTotal. Here's my process hashes, my SHA-256 hashes, SHA-1 hashes. Help me understand from VirusTotal, are any of these benign, are any of these malicious? And the ones that are malicious, let me know about so I can get them cleaned up. And the last one for now is process forensics. Remember, Tetration is a DVR. When a process kicks off, Tetration records. We watch that parent process and every child process that might have spawned off of that. But we also record what is the behavior between the parent and the child processes that have spawned off. Did we see a privilege escalation? After that privilege escalation, did we see someone try to access a file they shouldn't have access to? Did a web server all of a sudden try to execute shellcode and then open up a socket to move data off of that web server? All of that is behavior that should not be happening. Well, now I have that recorded as in my DVR, and I can use that for forensics purposes. So this is our solution today around cloud workload protection, and you can imagine the next time we get together, there'll be more applications that we're able to add to this to make more sense of this data, solve more complex problems, answer more questions. Now let's apply what we've done here back into the real world. Now, Tetration is a hierarchical whitelist policy platform. So what does that really mean? Well, if we've discovered a zero trust policy for an app, or multiple apps, well, InfoSec will always still want their intent, their business intent, security intent, layered across the organization. So what could that look like? Maybe InfoSec wants to start to define enclaves. Prod can communicate with prod. That's a pretty good rule that we should have. Dev should communicate with dev. Hope you're starting to see this. Let's get away from blacklisting and start whitelisting things so our rules get drastically smaller. Can I blacklist? Absolutely. But when I can whitelist, things get much, much simpler. Maybe I want to write something like my ATMs are allowed to communicate with my ATM infrastructure. Or maybe if you're running a CVE of 8 or higher, you can only communicate with my remediation server. But the whole idea is I want to define at the top of the hierarchy, this is the intent every workload must adhere to first before we ever get to that app's individual zero trust policy. So when we start to look at this, we have info or network security intent. Number one, right at the top. And then number two, each application's individual zero trust policy. Now I'm simplifying this. There could be multiple layers of different teams inserting security policy, but as a packet comes in, we flatten these rules and we enforce them in the proper order. So we make sure that you must adhere to these rules first. If you adhere to them, then you get down into the individual application's granular zero trust policy. Now, how do we tie this all together? If we start off with a workload that's sitting in dev, fantastic. We have a life cycle annotation that equals dev. Great. It matches on that rule right there. Okay. It's allowed to communicate with anything in the development environment and then anything within its zero trust policy. But over time, this workload's eventually going to get promoted into production. Now, part of the DevOps team in promoting that workload into production, we want a workflow that also tells Tetration, guess what? That lifecycle tag is no longer dev, it's now prod. The beautiful thing about this is this requires no user intervention. That workload's policies are dynamically going to change because its tag has changed. It now can communicate with things in production. No longer can it touch things in dev. And then as it goes through its life cycle, maybe at some point in time we find out it's running vulnerable software. And then hopefully this rule right here, most of the time has no endpoints in there for doing a good job of keeping things patched. But we know that's not always the case. But something eventually matches on that rule. It has a high CVE rating. Well, guess what? It's only now allowed to communicate with the remediation server until it gets patched. And then we can get it back into production. So it's a living, breathing life cycle approach to cloud workload protection for your workloads, no matter where they exist, on-premise or in the public cloud. I want to thank you for your time today, and hopefully you learned something new about how you can take Tetration and help you start to solve those complex questions and those complex challenges you've been trying to solve over the years. Thank you for your time.